Example number 2, determining the characteristics of a sine function based on its equation. So consider the function y equals 3 sine 2 times x minus 45 degrees. Describe the graph of the function by stating the amplitude, equation of the midline, range, period, as well as relevant horizontal translation of y equals sine x. Verify using graphing technology, and how would the graph of y equals 3 cosine 2 x plus 45 would be the same, or how would it be different? So we'll use our graphing technology for that. I just want us to remind ourselves of the format. Y equals a sine b x minus c plus d. So the amplitude, easy. Easy peasy, lemon squeezy, it's just the a. So that's 3. What is the equation of the midline? We're going to say y equals d. What? Y equals d. What? There is no d. So that means that d equals 0. That means the equation of the midline hasn't gone up or down, it's just at 0. So that is kind of like what happened with our c in the other one. We couldn't see it, so that the c equals 0, so it didn't move left or right anyway. It doesn't move up or down anyway, so y equals 0. Let's talk about that range. Remember, the max is d plus a. D is 0, plus a is 3, so we have positive 3. And our min occurs at d minus a, so 0 minus 3, which is negative 3. So if we are to talk about the range, it's going to be negative 3 is less than or equal to y is less than or equal to positive 3. Y is an element of the reals. Okay, let's talk about the horizontal translation. Oh, first actually let's talk about the period. Now we're still in degrees. How do we know? Because I see right here 45 degrees. So the period equals 360 over b. Let's identify here what b is. Our b is our 2. So I'm going to say 360 divided by 2. Just going to use the highlighter again. This guy right here. So 360 divided by 2 is 180 degrees. So that means that every 180 degrees, the pattern repeats. Last but not least, horizontal translation. Now from the original function y equals sine x, we're saying that it's x minus 45. So we're going to say that it moves to the right. Okay, because it's opposite. The x's are always opposite. It moves to the right 45 degrees. Okay, let's graph this thing. So I'm going to say that this one right here, let me just get the function in view. So 3 sine, actually I'm gonna give a good example here, okay? Clear it first. 3 sine 2, open bracket, I'm gonna open bracket again, x minus 45, close bracket, because I need to close this bracket, and then I need to close this bracket, and then no plus d or minus d, so we're going to graph it. Look at that. So what we need to do is, we can't see the whole thing, so we're going to change the window settings again. We're going to change them to window. I'm going to go down to -4. Let me see it. Alright, so the full range here is from 3 to negative 3. So we got the range. We're saying the equation of the midline is 0. Yep, half is above, half is below. The amplitude, the distance from the midline to the max or the midline to the min, is 3. That's true. 1, 2, 3. Good. The period is 180. Now we can check here from max to max, so that's what we're going to do. Actually, this one's easier to go from the minimum, right? Because this will occur at 0. So I'm going to go second trace minimum. I'm going to go left of that just to ensure that it truly is x equals 0. You going to give me some crazy number? Yeah, you are. That's okay though, because we know that anything e to the negative, negative 6, even to the negative 5, we're going to say that x is 0. Okay, so then what happens to the next minimum? Let's get over here, left bound. And I like to get a little bit closer. I suppose I could have put the left bound farther away, but the next minimum, 179.999999998, which is essentially 180, which is exactly what we want. Perfect. Now, how would you graph? How would the graph of y equals 3 cos 2 times x plus 45, would it be the same or would it be different? I don't know. Let's figure it out. So I'm going to go here, and what I want to do is I want to make it a different line. Okay, so this is going to be a little bit thicker. So I'm going to say 3 cosine 2, and then open bracket again, x plus 45, close bracket, so I close this bracket. Now I need to close it again. And I have no d on this one either, so I'm going to graph it. Look at that. Now here's the thing. Amplitude, the same. Period. The same, because it takes the same amount of degrees to have it reoccur. The only thing that's different is that shift, and also the changing of the trigonometric ratio. But the only thing that is different between a cosine graph minus 45 and a sine graph minus 45, x minus 45, and a cosine graph x plus 45, it's just a horizontal shift. Okay, the range is going to be the same, the amplitude is going to be the same, the period is going to be the same. The only thing that's different is that horizontal shift.